Hello, so I've been working on field of view stuff again. I had left this behind because I wanted to focus on this towards the end, but I started to implement some sort of little creatures to actually start messing about with things that the player can actually interact with. And as a result of doing that, I needed to be able to determine if units can see creatures. And in order to do that, well, one method of doing that is to actually use the same algorithm that generates what the player can actually see on the screen. So I thought it'd be worthwhile to actually give that a go. It's really sort of a prototyping kind of thing to see whether it works or not, and it seems to work okay enough to use, which is lucky. So if I just try and what I'm trying to do here is build a level that has enough sort of twists in it that will obscure vision a bit. I haven't really got sufficient different types of pieces to really sort of lend itself. The elevator will help though. Okay, so if I just hit run, now where is everyone? Okay, here. So immediately you can see these little cubes running around, these little boxes. Now these are kind of little creatures, and the AI for these is just they're just moving about randomly. This is when I started looking at targeting, so units being able to shoot at the little creatures. I'm not sure why everything seems to here be faded a little with the colouring. So as part of the field of view algorithm, well, you can see it working. You can see it hiding areas that aren't visible to the unit. It's literally covering everything up, so you can't see what's behind. And I think it should be possible to use this to determine whether units can actually see creatures, to actually test whether they're in this region. I'll just show the elevator. Now, one issue with the way the elevator currently works is to get on the elevator. You can't directly get on the elevator. You have to actually select a location on another floor. Now, if you can't see the other floor, it's a bit of a problem. Fortunately, I know it's up here, so I can just hover over and find it. But one option is to, instead of hiding everything, is to actually grey it out a little. In fact, I should just be able to quickly show that. Yeah, so this is all now greyed out. The downside with that, well, there's two downsides, I think. Well, the biggest downside is you shouldn't be able to, even though you've seen that area before, so you remember it, you shouldn't be able to see enemies. So just greying out isn't sufficient. It's one of the bonuses of literally covering it all up, is that you can actually hide everything. The other downside is there's no kind of mystery to what's down here. You might not have visited this area before, and yet it's still shown. So I'm kind of leaning away doing this. I might just allow units to get onto the elevator and then say go down to the next floor. You'll notice in a situation like this it works okay, because even though, let me just set it back to show what I mean. Even though you can't, at the moment you can select up here, I'll probably try and change that so you can't, because you shouldn't really know what's up here if you haven't been there before. But you can nudge closer, is what I mean. You can just slowly nudge closer and uncover it, which is probably fine for the player to do. It's just elevators that present a problem, because you really just can't see the floor below until you get on. So that's the field of view and these little creatures. I have only got one unit on at the moment because this is only working with one unit so far, so I've got to update it. But one of the other changes I've made is that selecting multiple units and directing them to a location, they now don't occupy the same position, which they were doing before. It's not completely ironed out. All of these things are really sort of rough at the moment, until I've pinned down how the features, made sure that features are going to be actually in the game. I don't want to spend a lot of time completing them 100%. So yeah, that's basically the field of view stuff. I might at a later point create some sort of tutorial video in case anybody finds it useful. I will find it useful actually, because I'm sure in a week I'll forget how this is working. I could do a quick sort of overview now. I haven't really, probably haven't got all the steps quite correct to actually talk about it in a lot of depth. So the way this is working, well, it looks a bit surreal now in the editor view, and this is because there's actually three different renders going on. If I just try and stop the camera. So in the background, I'm not entirely sure why. Let me try and center the camera. Okay, so you can actually see that behind here there's this separate. Now, there's three cameras effectively, but they occupy the same space, so kind of they're the same camera. They're treated as the same camera. For one of them, there's a texture, the normal map, everything in the map is rendered. So this render texture here, which I call just the main screen texture. This is down here in the bottom right. You can see everything is rendered to that texture, and then from a separate camera, just this FOV polygon is rendered, which is this green area here, and then these two are combined, and the final result is effectively rendered to the entire screen. And the combination of these two is what basically hides areas of the map that can't be seen. The real sort of bulk of work in this is the generation of this polygon, this FOV mesh. Well, I've called it an FOV mesh here, and the algorithm I'm using is similar to the one from this. I think I might have mentioned this in an earlier video. This algorithm. So they've got an example on this web page. Most of all these examples are top down. Of course, I'm using it side on, but it's still the same thing, 2D. The way this one works is that from a given point, it actually does raycasts out to test for collisions with edges, going towards each corner, each edge corner, and then as a result of that, you can see the resulting polygon is actually a series of triangles. And the thing I thought about with this is quite useful if you've got if you want to see whether if your unit can see enemies. All you've got to do is test whether the enemy intersects with all of these triangles. So this is what I was kind of looking for in terms of co-opting this. This thing is entirely just visual at the moment, so these enemies can't use it at the moment. It's entirely visual, but they should be able to be wired up to use this, effectively this green mesh here. So the enemies can use that as well. So this green mesh, you see it changes down here as I move around. This actually belongs to this unit, so a different unit on the map would have its own one. They can overlap, but the useful thing about these polygons is that the unit can actually test to see which enemies are within the polygon. Any enemies that are, it can see. Conversely, you could have hundreds of enemies, but they've only got to check to see whether they're in the unit's polygon to know that they can see the unit. That's assuming that both their sight ranges are infinite or the same. There's no soft edges with this as well. There's possibility that I might put soft edges in, but I don't really see it as a kind of problem at the moment. That'd just be an entirely visual thing. So yeah, this algorithm here, somebody actually in the comments down here suggested a faster algorithm that got added to the references here, which is reasonably recent. This paper here is efficient computation of visibility polygons. The actual algorithm, because they discuss other algorithms and then they do some experiment to test the performance, it actually runs, I think it runs faster than the one on the website, and the algorithm seems more robust to me because this one here has some special cases to deal with. For example, this line here that travels up here, it hits the corner here, but it also has to continue. So there's some sort of hacks to get that to work, whereas this algorithm might be slightly more complicated in the way it works, but it just seems more robust. So instead of doing raycast against edges, what it does is it say what triangle are you starting in, and then it recursively goes through the edges of the triangle and then through the edges of that triangle, and then continues going through every triangle until it hits an edge which is a wall, and then from that it builds up the same. I get the same shape at the end. This kind of polygon where it's all made of these triangles, which means I can do the visibility test for it. The reason why this is faster, or the main reason why this is faster, is that it requires pre-processing to be done ahead of time. So it's basically the geometry that you want to do the vision test on has to be triangulated, divided up into, see, like for example, all these triangles here, and obviously you get a huge boost in performance if you only have to do this once at the beginning of the level. So I was looking at ways of avoiding having the geometry changing dynamically. I've got doors and I've got elevators, but you see what I've done with the elevator is I've just treated the entire elevator shaft as visible, because I figure there's not really going to be any enemies in there anyway. Once you're in the elevator shaft, you could say there's a hatch on the top, you can see it, even if it's an enclosed elevator. So you see the entire elevator shaft, so there's nothing dynamic there. In terms of doors, I've decided that a door will just be an on-off, so it will just be an edge and it will just block. You can do that dynamically, on-off an edge. Yeah, so I might cover the implementation in a tutorial video at some point, because the data structure that you want. There's a certain data structure you want for it to be as fast as possible at runtime. It's not mentioned in this paper, but when you sort of implement the algorithm, you suddenly realise that, oh, actually, you don't strictly just want a huge blob of triangles. You actually, it's almost like a tree structure of going through one edge and then which edges are linked to that and so forth. Yeah, that's about it for now. I'm going to try and get multiple units working with this, because I am slightly concerned about the performance of this and how many units the player is going to be able to have, because now there's both. I'm not too worried about the CPU impact, because it's just a few render textures, but the CPU impact, because at the moment this polygon's being calculated every frame. If you got like 10 units all calculating these polygons, there might be a bit of optimization requirements there. I'll see how it goes. I was originally in this game planning to have dozens of units the player controls, but that might not even be a good thing for gameplay. So I could end up limiting it to say like 8 units or something like that, if the worst comes to the worst with it. This will also support one of the main reasons I went for this. I think in the previous video I talked about actually just calculating these placement points and seeing which ones are visible from which ones. I started looking at flying units, or flying enemy units specifically, say within large rooms, and of course then you'd have the issue that the placement locations aren't fixed to the floor. You're going to need some in mid-air, and you start to get a more sort of grid based field of view, which doesn't really look that good when I did it. If you try and make the grid too small, you end up with performance issues, and then you might as well do it like this anyway. The nice thing about these triangles is because these triangles, actually, if I click on one of these rooms, you can see these these cyan triangles. These are actually hard coded for each section, because the rooms I've got are really simple at the moment. Hopefully they'll just stay simple. They can be represented as very few triangles, like these corridors are only 2 triangles, for example, and this big room's only 4. But if you've got like outside areas or huge rooms, they could just be 2 huge triangles, and the algorithm would work just fine. And that also means that flying units will be able to say which triangle am I in, and they'll be able to work with the visibility stuff. The other thing I'm going to be looking at is getting doors finally working. These little creatures currently, I haven't got doors on here because as a result of doing this render to texture stuff, the on mouse down handling which I had, it's working with navigation because I do that slightly differently, but for opening and closing doors it's no longer working. These little things don't go through doors at the moment, but I've got no way of opening and closing the doors to show that. So I'm going to work next on fixing that up, and one of the enemies, or several of the enemies, are going to probably all of the enemies, apart from the smallest ones, are going to have the ability to be able to smash through doors. So I need to start thinking about how that's going to work. Yeah, so that's it for now. Thank you for watching.